He's a product manager for ASI Automotive. He has worked in the EHS, LMS, CMS, logistics, private, public, government, and military spaces. He has built enterprise solutions, formed teams, and developed sustainable systems for growth in both products and sales from the ground up. Now at ASI Automotive, he's a passionate missionary for safety, efficiency, and repeatable testing results using robotic test drivers for ADAS AV, durability, misuse, and impact groups. So I'll go ahead and turn it over to you now, Jed.
All right. Well, thanks, Fred and Zane, for joining us today. And we will be talking about revolutionizing L2 to L5 ADAS testing with multiple actors using robot drivers. So an interesting use case and a very flexible solution from our perspective. So glad you're here. We'll step through and look at, first of all, some of the challenges that we've noticed in talking with people that are doing ADAS testing. And in May of 2022, the AAA recommended that automakers should focus on refining ADA systems performance in the context of edge case scenarios involving other passenger vehicles and vulnerable road users. So some of those problems, safety critical and near crash events with an engaged ADAS, can only be tested in simulation, are not safe for human drivers, especially in those extreme or near crash events and edge case scenarios. And especially trying to do that in a repeatable manner is very difficult. It's cumbersome to choreograph. And when often when they do the integration tests, is typically just testing fault tolerances and individual components, not really testing everything comprehensively. And then the real world testing happens with the safety rider in these systems that aren't fully tested out on the public roads. I have a 15-year-old, he's going to be driving soon. It makes me extremely nervous to have him out there driving. So what are some of the challenges that you guys are facing? You can type those into the chat. We'll try to answer those. And also at the end of the presentation, we would love to hear what types of innovation are you working towards? Is there some way that we could work together for that innovation? So the chat is available. We'll have some time here. We're going to jump in and look at a video that explains how swarming works. But have you seen a difference in how simulation works versus how things work in the real world? What are those ADAS features that you're working with that are difficult to validate? You know, automatic lane keeping, the advanced emergency braking, just the timing of those, and how many actors you need for some of those scenarios. You have others that are troublesome. So we're going to jump in and look at this video quick that explains how swarming works. So pop some corn, turn up the volume. We got 4 minutes. Oh, sorry. All right. So that's a little bit about swarming, just a preview of what that looks like. So some of the difficulty that we've seen is that we go from ADAS testing and simulation, which doesn't always equate to how things work in the real world. We test individual components, make sure that the faults fire. Then we go to testing on the public roads. We believe that there's a gap in there. And that's what ASI swarm testing, that's the gap that ASI swarm testing fills. So what this allows us to do, like currently what we're doing is according to the levels of driving automation, we're currently testing at the L2 plus level, which means that we're still technically in the driver assist realm, but we're incorporating a new layer on top of traditional ADAS testing features. And this could be used for L3, L4, L5 testing. And by using the robots, we're able to use a number of different makes and models. It doesn't have to be the latest or even an autonomous vehicle in our testing, which means, especially for some of those tests, you don't have to have the latest and greatest, and you can still use other vehicles around it. So swarming helps us to test beyond the simulation. Uh, you can export paths from your simulator, and currently we're exporting from Open Scenario 1.1 standard and importing those into Mobius to have them run on actual vehicles. This provides you with where you can maintain your desired test atmosphere, but then adjust for high, low speeds, and you can adjust your actual vehicles by centimeters, just like you can in simulation. This allows and makes sure that all the components are working in the physical world where they're ultimately going to operate. So we had a major car manufacturer approach us. What they wanted to do, they required a safe way to test their new L2 plus ADAS features in the real world conditions. In simulation, they designed a number of tests, but they designated 16 of those where they had 3 to 5 target vehicles would be choreographed around their L2 plus host at speeds from 25 to 70 miles an hour. They felt that if they could replicate these tests at least 3 times while mixing the fleet of vehicles in different lanes during these scenarios, that would be enough to validate the simulation results in the physical world. This way, they would feel better equipped for putting a safety rider in the vehicle and for starting that testing on the public roads. The test became dauntingly complex, riddled with concerns of operating multiple real vehicles safely, accurately, and in exactly the same manner for each test. These scenarios were designed to test multiple aspects of their L2 plus ADAS each time. For example, automatic lane keeping with the ACC and traffic jam assist. They observed differences in how the L2 plus performed in the real world versus the simulation. So this was the challenge. ASI swarming with the driving robots was the ultimate solution. Our robots were able to drive the exact same simulation scenarios over and over without an increase in stress or fatigue. This narrowed the variances to the engaged L2 plus ADAS for algorithm engineers and the implementation engineers to zone in on perfecting the solution and its integration, knowing that the target vehicles would execute the scenario with precision every time without any bias. During the final tests, the OEM planned 8 days to validate their L2 plus ADAS. With ASI swarming and robot drivers, they were able to complete the tests in less than 1 week. Originally, they had anticipated running one test in the morning, one test in the afternoon, each day in order to complete the test schedule. But with the driving robots, they didn't encounter those failed scenarios and were able to choreograph multiple target vehicles precisely to the simulation with the push of a button. No matter which vehicles or lanes were selected, the robots were able to drive it each time, allowing them to advance from one test to the next more quickly than expected. And I think those that are working with the semis, this is a great use case as well. Especially, we used to have back in the 1900s where I live, we had commercials that would talk about driving trucks smart and just the dumb things that passenger vehicles do around those semis, and it's dangerous. So having a robot in some of those or in those vehicles, um, you can remove that human from the situation and do those dumb maneuvers repeatedly over and over again so that that ADAS has a chance to respond. So here's another example. Let's look at this. In this example, the host ACC is set to 45 miles an hour along with an orange vehicle in the front, and it's following at a safe distance. The white vehicle is going 40 miles an hour, so it's going 5 miles per hour slower. It's going to cut in front of the host, and then there's a truck that's going 35 miles an hour. We're going to pass that. And you'll see here where the ADAS gets engaged and the white car pulls in front, and that's going to provoke the response from the ADAS. And with the robots, there's definitely a pucker factor if you're a safety rider in this, depending on the speeds and how fast that host vehicle comes bearing down on you. But those robots, they don't feel that. So this is some of the magic right here that illustrates how well the robots are able to drive these scenarios compared with what the simulation specified. So let me step you through this. This dark green represents the speed of the actual vehicle. The light green is what the simulation specified. And you can see that's very different. The simulation is very even, but in actuality, the vehicles, they shift on those acceleration. And then this blue line is showing whether the vehicles are ahead or behind where the simulation said it should be. So here you can see that the robots are going to command each of those vehicles. And in this case, this is the host vehicle. It gets it up to about 29 meters per second and engages the host ADAS. Then it goes hands off and it becomes a safety rider. It's checking the lateral movement of the vehicle. It's checking that it's not too far ahead or too far behind. And if any safety parameters are crossed, all the robots are going to be activated and bring all vehicles to a safe stop using V2V communication. We call it smart stopping. So in this case, we get it in the ADAS engaged, and then the target one vehicle gets up to speed. It's going about 27 meters per second, pulls in front of the host, and you can see it provokes that response. The ADAS, host ADAS system engages, slows the vehicle down, and then here towards the end of the scenario, in this example, we disengage the ADAS, and then the robots bring all vehicles to a stop according to their stopping profiles. But we have had where there's not a disengagement, and we're testing the traffic jam assist, where we command the robot vehicles to come to a stop, and the traffic jam assist brings the host vehicle to a stop. So in conclusion, robots can take that pucker factor out of ADAS testing. They're safe. You can test at the high or the low speeds, and we're removing human drivers from the vehicles when we're performing these safety critical and near collision events. Robot drivers act as a safety rider and monitor the vehicles continually. They can monitor anything that comes out of the can. They can monitor the lateral movement and also the accelerations. We can test edge case and near crash ADAS responses with multiple actors with just the push of one button. Mobius will choreograph all of the actors for us, and multiple ADAS features can be tested in a single scenario using multiple actors. And this was really designed to scale up from the 6 actors that we're using currently to 20. And in fact, this customer here has some Harley Davidsons that they want to add to these scenarios next, and we'll be moving on to testing an L3 system this coming year. It's comprehensive. Robots don't suffer from the same pucker factor as humans. They can perform those safety critical and near collision events or regular events over and over without an increased stress or fatigue. They remove a human bias when people know or are anticipating a stop or a weird event or something that is perceived to definitely. I've been there. Pucker factor. Um, and they'll do that repeatably over and over again, same profile. And they remember where to line up. They remember how to start the vehicles. They remember the acceleration profile. They remember the deceleration profile. They remember the cut-in distances. And so you can retain your test atmosphere while being able to adjust real-life vehicles by centimeters, just like you could in simulation. This helps to validate real-life scenarios in real life before putting the vehicles on public roads. Swarming fills that gap between simulation and testing on public roads. We would love this. This is extremely flexible. It's innovative. Uh, we're not tied to just one set of tests. We train you on how to create your own tests, and how to import those into Mobius. Um, so we would love to work with you and hear what kind of innovation you're looking for on the proving grounds. Again, my name is Jed. Eric Budd's on the call here as well. But we'd love to open it up to you for any questions or ideas that you've got.